Two and a Half Admins, episode 7. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, Alan, you've got something to plug.
Yeah, so this Saturday, which I guess is the 11th, Tom Jones and I are running a FreeBSD bug squash. So if you're interested in helping close a bunch of bugs for the FreeBSD base system ports and documentation, then you should come out and hang out. We're basically going to have a big Google Hangout type thing with a bunch of people working on stuff and talking about it and sharing what they find and so on. It should be fun.
All right, well, we're going to do some free consulting a bit later, but first let's do a bit of news. And we've got some initial benchmarks from Apple's ARM-based developer transition kit. This is the Mac Mini with an iPad Pro CPU in it, or system on a chip in it, which you have to pay Apple $500 for the privilege of borrowing to port your apps over to the new Apple Silicon, and then you have to send it back. And you're definitely not allowed to share any benchmarks or anything, but that has not stopped people.
Apple developers, what are you going to do, man?
One friend of mine has one of these for working on the port of OpenZFS to iOS, which maybe we'll have to be able to work on ARM.
iOS or macOS?
I guess macOS.
Yeah. That'd be funny to have ZFS on an iPhone.
Well, at one point, Samsung ported ZFS to Android and made it work with only 64 megabytes of memory, but they never finished it for one reason or another.
Yeah, I mean, to be fair, ARM, macOS, and iOS are not going to be that divergent, most likely. So you're pretty much going to get one for the other, just about.
Yeah, macOS has quite a bit more different kernel than some other things, but like Linux and Android, it's the same Linux kernel.
Well, macOS has a very different kernel from iOS, now, but when they're both on ARM, I don't think that's going to be the case. Apple's already said that you're going to be able to natively run your iOS apps on ARM Macs, no Rosetta needed, they just run.
It's kind of the point of writing code in C and other languages is that you compile it and it doesn't care what CPU you're on.
But these benchmarks are using Rosetta too. So that's the translation layer.
Yeah, the benchmarks that were leaked were running Rosetta 2. So they are x86 emulated on ARM, which means that they're probably going to be roughly half the speed that you might expect to see on ARM. That's a very, very rough fudge factor, but it's not unreasonable. Emulating an entirely different hardware architecture is far slower than just traditional virtualization.
Yeah. So I imagine eventually someone will port some benchmarks like Geekbench or whatever to run native, compile it natively to run on ARM, and then we can get more useful numbers.
But it looks like it's roughly equivalent to the latest MacBook Air.
No, not the latest MacBook Air. It's a several-year-old MacBook Air, and it's the entry-level one, not the big bad boy. I want to say it was an early 2015 MacBook Air, and the actual processor's an i3.
Oh, okay.
It's really, really hard to track all these things down. I did, and it took quite a lot of work because all Apple people want to say is, oh, it's just like a 2015 MacBook Air. And, then on top of that, it's the early 2015, not the late 2015. And that's different, too.
Yeah, I don't know why Apple can't have a fucking model number. I flip over my MacBook and I'm like, I'm not sure which one I have. It's the early 2016, I think, or something.
Well, they do have that 2,1 or whatever, don't they?
A little bit, but it's very vague and doesn't generally tell you exactly what.
Yeah, that can cover a lot of different specs, can't it? So
Yeah, and for my MacBook Air that I bought refurbished and loathe immensely, it's an early 2013 MacBook Air, which I didn't really care enough to figure out until I was trying to figure out, whether or not the latest version of macOS that just dropped would run on it, and it will not. Mine just missed the cut.
Yeah, mine's a relatively basic one because a sponsor was giving them away at a conference, and I happened to win, so it was like a base spec one. Which was good because it means it didn't have this silly touch bar. It has a real escape key.
Not only is there not a model number, but even the whether or not you get to use the new operating system doesn't even break cleanly along year lines all the time. In some cases, you have to worry about, do I have the early 2013 or the late 2013? It's insane.
Yeah, the worst part is they don't tell you, though. You just have to stop getting support and then work it out yourself.
Well, yeah, this was our complaint with the the SMR hard drives. Is it's like, just tell me what's inside the damn thing so I can make a decision.
That's not really the Apple way, though. They're like, you have an early 2013 MacBook Air, and it's a complete thing. There are no parts. It's an experience. You have the experience.
It's interesting, though, that this CPU presented as a quad-core rather than an octa-core, because it's got that like big little thing going on, and the benchmark software couldn't tell or something, maybe.
That's not surprising at all, because remember, it's going through Rosetta. So you're emulating an x86 environment, and x86 and Big Little are not exactly a common mix.
Yeah, so I'm guessing it maybe had to like make up fake ACPI tables or something. It was just like, it's easier to just say we have this many cores.
Yeah, just ignore the 4 little cores, and here's the 4 big cores, and we'll work from that.
It might be that the application might want to try to choose to do things with certain cores, and so rather than expect the applications to know about big and little, you're just like, there are 4 cores. And sometimes when you choose core 3, it'll be a little core 3, not a big core 3.
Maybe. I mean, we don't really know how Rosetta 2 is handling that architecture.
Right. But I even mean when you're native, it might still only tell you there's 4 cores, and then the OS decides whether you get to run on the big or the little core.
I find it a lot more likely if you're running native, you'll probably see all 8 cores. You may or may not get to choose which one you run. It may still be the operating system that schedules it, but I don't really see why you would hide that exactly.
But the chances are that these CPUs are not going to be the only thing doing the work, right? There's going to be loads of other specific chips that handle the audio and all the other stuff. And it's going to be sort of spread out among various Apple silicon, and they will obviously tune it all. So these initial benchmarks really don't tell us that much about how native applications are going to run on OS 11.
No, not at all. What's interesting about these benchmarks is they give us a floor, and a lot of people, myself included, were a little skeptical about how well this was going to work out. Trying to run a full-fledged operating system on an ARM architecture, and not just this little thing for a phone or a tablet that doesn't have to do all the same things that a full-fledged operating system that exposes all the device's functionality does. So knowing that, even on this really early dev hardware, even running through Rosetta, we're getting very usable performance equivalent to a fairly recent, retail laptop. That's really encouraging. It says, it's not going to suck. I feel like it's very safe now to say this isn't going to suck. How great it will be remains to be seen.
Yeah, like if you've ever tried to use QEMU to emulate ARM on x86, because if you're going to compile stuff for your Raspberry Pi, it can be a lot faster to do it on a big AMD 64 computer, and then using QEMU to emulate the ARM architecture. Even there, that's usually not that fast. And so seeing the other way around actually being reasonably fast is quite interesting.
Yeah, ARM QEMU on x86 hardware, I would go further than saying it's not particularly fast. It's usually nightmarishly slow, in my opinion.
Well, it's usually still faster than using the native Raspberry Pi.
Yeah.
Then a Raspberry Pi, sure. But
right.
I'm comparing to, I tried for a while. I thought it would be really neat if I could run, my favorite Android games in QEMU on my PC. And it does not compare well to, a decent phone.
That's what Android x86 is for, surely.
Well, that depends on the game distributing an x86 compiled binary, right?
Yeah, exactly.
True. All right. Well, an article that was making the rounds over the last couple of weeks was from jeffgeerling.com. I think that's how you say his name. And this is about UASP, something I hadn't heard of before, and a Raspberry Pi 4 and connecting USB disks to it. And if you've got a disk that supports this UASP protocol, it is potentially a lot faster. And I had no idea. I thought USB 3 was USB 3, but this week I learned.
Yeah. So there's basically, over USB, there are different protocols you use to actually talk to a disk. And the one you're mostly familiar with before is bulk only transfer, which is just transferring chunks of data. But yeah, there's this newer one that's basically USB attached SCSI. And it's basically designed to expose the USB storage more like an actual hard drive. I'm not sure why they wouldn't have opted for something a little bit more like NVMe for this, just because that protocol lets you do more, but maybe it doesn't map to having spinning disks, right?
How can SCSI be faster? That's an ancient standard.
Yeah, but SCSI is the protocol for just how you encode the commands.
Yeah.
Technically, SAS, Serial Attached SCSI, is the fastest available transfer protocol. Like, it's what all of my big, really fast servers use, 12 or 24 gigabit per second SAS. And it's all still that same SCSI protocol.
Yeah, Joe, I think part of the issue there is you might be confusing the idea of the SCSI protocol with particular implementations that ran at a particular wire rate. And that's not really what we're talking about here.
Right, because I associate SCSI with the hard drive that I dug out of my dad's ancient Mac that I then had to get a PCI card for and hook up to retrieve all his files and everything. So SCSI to me just feels, I'm afraid that was before my computing.
Right.
I came in the IDE era, so SCSI was just not something I ever encountered apart from that one time. So that's why I consider it to be old in my head.
Well, it's not so much that you're too young for SCSI. It's just that, you were too consumery for SCSI. I mean, SCSI was certainly still a thing while you were using IDE drives. It was just more expensive, and you mostly found it in, more of an enterprisey type setting.
Right. I see.
Like Alan said, SAS is still SCSI. It's literally serially attached SCSI. And to put it in perspective for you, Joe, so you don't think SATA is ancient, right? Like it's what you use every day.
Yeah.
But what you're actually using every day is SATA 3. Before that, there was SATA 2. And before that, there was SATA 1. And the big difference between SATA 1, SATA 2, SATA 3 is, the actual wire rate, whether it's 150 megabytes a second, 300, or, now 600. But all of them are still SATA. Well, in a similar way, SCSI, whether it's, in USP or SAS now, it's the same SCSI as way back in the day. And I'm not as intimately familiar with the names of the, wide and narrow and whatever going back in the day, but it's gone through the same evolutions where the wire rate increases while the protocol itself doesn't change.
That's the one that's confusing, is that kind of both halves were called SCSI, the interface and the protocol, whereas for your IDE hard drives, the interface was IDE, but the protocol was ATA. And we still use that ATA protocol on SATA. They're serial attached instead of parallel attached. But the actual commands you send to the disk, like, read, write, and the smart commands and so on, are still the same as that, 8 gigabyte IDE hard drive you had. We're still using that same command set to talk to the 12 terabyte SATA drive. And that is why the NVMe protocol as a replacement makes more sense for Flash, because the ATA and SCSI protocols are both based on this idea of the disk can only do one thing at a time. So you can queue up commands and say, do these 5 things. But with NVMe, with Flash, it's basically an array of a bunch of separate chips. So if you can give it more commands that it can do at the same time, it can get more work done. And so NVMe protocol allows basically submission and completion queues saying, all right, here's a whole list of different things to do. And then as you get them done, put them in this other pile and I'll come pick them up as I can. Because the other thing is the Flash is so much faster. Like the latency is decimals of a millisecond instead of, tens of milliseconds compared to spinning disks. And so most NVMe devices support receiving 63 concurrent different commands to do. And each of those 63 queues has a queue, like a list of things it can be doing. And then there's actually 64, the extra ones saved for admin commands, so they never get stuck in line behind other commands. And the protocol supports, much wider, having as many queues as you want, thousands. But most devices currently only bother with 63 because, nobody's got the number of CPUs you would need to be able to run that many different things concurrently.
Although in theory, ARM might change that as well, because we're seeing pretty high concurrency in a lot of the new data center ARM designs.
Yeah.
But this UASP thing doesn't just apply to Raspberry Pis.
Right. I think the difference will be bigger on a Raspberry Pi because the CPU is that much smaller and slower and so on. And because the USB bus is that much weaker, you're going to notice a bigger difference by doing the more optimized protocol. But yeah, there's still advantages to get this on your regular PC and so on.
Yeah. Because I spoke to you about this recently, Jim. You said that a Raspberry Pi makes a terrible NAS. You should never try and set one up. It's just not even worth it.
Correct.
Yeah. They are relatively unreliable. Like the parts are made as cheap as possible. And there's just, USB attached to everything, and they're just flaky.
The USB attached to everything is really the big killer. I mean, everything is bottlenecked because everything's attached over that USB bus. It's not just your storage, which is bad enough, but your networking is also limited by being attached over USB. And it's not, this is not like a blazing fast USB either. It's a USB on a little bitty ARM device.
I thought that with the Pi 4, they'd separated it away from the Universal Serial Bus.
The Pi 4 might have a separate, like a real network card instead of just a USB attached one, but there are some other ARM devices that do as well. But really, if you want to go that direction, there are hardware that's made a little more specifically for that type of thing. Like they make small ARM things that are meant to be used as a little server or whatever. Like really, if you want an ARM-based NAS, you want something that has SATA ports.
Yeah.
For the disks.
Yeah.
And real NIC.
Yeah. Or at least a PCIe port that you can plug a card into.
Yeah.
Yeah. The Raspberry Pi 4 is not as limited as the 3 and prior were when it comes to network throughput. You can get full gigabit throughput out of it. The issue is not necessarily just, whether it's USB attached or not, but on the Pi 3 and earlier, the network was attached to a single shared USB 2.0 channel to the system on chip. So you couldn't get more than, about 250 megabits per second or so through it, no matter what you did.
Yeah, like I think with the Pi 1, you were topping out at like 64 megabits. It was sad.
Yeah, you didn't actually break 100 megabit until the Pi 3 B.
Yeah, I'm not sure about using it as a NAS. I did do a test over the last couple of weeks with a Pi 4 and 2 USB disks with not ZFS because Ubuntu didn't support it for some reason, and I couldn't be bothered to dig into why. So I just set up a basic RAID on it, and the performance was terrible. It was like maybe 15 megabytes a second or something, and that's 2 gigabit Ethernet connections. So yeah, performance-wise, it's terrible, and reliability, USB is never the best, is it? So fair enough.
No, it's not. And like you said, you're still stuck behind USB for the storage, and that's not a great answer for either reliability or performance.
Yeah. All right, moving on then. Let's do a bit of free consulting. If you want to get in contact with us, the best way is show@2.5admins.com. Send us an email with your questions for Jim and Alan. And if you want to support creation of these episodes, then you can do so on Patreon. Just go to 2.5admins.com and there's links there to everything that you need to know. So Gavin writes in, since the early dial-up days, I've always set up and run my own Linux internet gateway, routing, DHCP, DNS, etc. First, it was basically a necessity, but now fewer people bother letting their plastic ISP router do all the hard work or buying all-in-one kit from the likes of Ubiquiti. Do you manage your own internet gateway at home still? If yes, why? If not, why not?
I do. I think that's extremely uncommon these days. And the major reason that I do is sheer paranoia. There are a lot of complex things going on, and there's a lot of attack surface on a consumer router. Even if you trust the vendor completely not to be doing anything shady, just, there's a lot of custom code there that isn't necessarily getting a lot of eyeballs on it and does a lot of things that you maybe don't necessarily need to do. And there's a lot of malicious eyeballs on that code, looking for ways in. And I'm a little bit too paranoid for that. So I ended up, just doing a vanilla Ubuntu install on a, small generic Celeron PC and doing routing that way. I honestly wasn't sure when I set out to do that what the performance level was going to be like compared to a really high end multi-core ARM router. It does absolutely kick the snot out of consumer gear. I will tell you that. It's even faster than like pfSense or OpenSense on the same hardware. It is significantly faster.
Oh, this is just Ubuntu with a bunch of IP tables manually configured.
That is literally what it is. It's Ubuntu, it's IP tables, and I'm running Bind9 for the DNS and ISE DHCP server to hand out addresses. That's it.
Yeah, mine's basically the same thing. It's a FreeBSD box. It's a low power E3 with 4 1 gigabit NICs because I have a bunch of different segments to my network because there's a rack that's in a demilitarized zone basically, and then the house and the office and then out to the internet. And yeah, it's basically does a little bit of NAT, ISC DHCP server to give out addresses and to netboot stuff that's in a certain VLAN. And I use Unbound for just, a caching name server.
So, Alan, the implication here is that the rest of your house is fully militarized. Is that correct?
Yes. If you cross into the other parts of the LAN, you will be shot. And it had to be able to do V6 and so on. And it had to be able to do it all at full gigabit. And so it made a lot of sense to do that. Like you were saying, the biggest thing I worry about with those off-the-shelf routers is the number of them that are still like Linux 2.4 and 2.6 kernels inside. Because most of that hardware, you're looking at 8 to 16 megabytes of flash storage for the whole operating system, and then maybe 32 or 64 megabytes of memory. So just the state table for the NAT and so on, you don't get much room. And that's why you generally see a lot better performance coming out of any old PC with some network cards in or whatever in it running, whether it's Ubuntu or pfSense or whatever. Be interested in what performance issues you ran into using stuff other than Ubuntu, because, for doing 1 gigabit, like any computer should be able to do that without blinking nowadays.
Well, the hardware that I'm using, it's not, you wouldn't want to use it for a desktop.
Right.
It is generic x86 hardware, but we're talking, like Celeron J1900s. It's like a 10-year-old Celeron.
Yeah.
It will absolutely do gigabit without breaking a sweat, and you can't tell there's anything in between you and the internet if you're doing a completely clean vanilla Linux install and just IP tables. I don't know what pfSense and OpenSense and those folks are doing.
I guess just too much other stuff and trying to draw graphs and stuff in the background all the time is just chewing up too much CPU.
I don't think that's it. I don't know. I have not tried to disassemble their stack and figure out exactly where things are going wrong.
Admittedly, I've not used a pfSense in 10 years because I've just had my own box as well.
Yeah.
It is a little bit of work, but it's usually not that hard, and it's generally pretty low maintenance. You do have to maintain it, otherwise it becomes just as bad as the Linux router that doesn't get updates, right?
But that maintenance is like super freaking easy. I mean, for the most part, like if you're coming from Ubuntu or Debian like I did, apt install unattended dash upgrades and ta-da, it gets updated. You're pretty much done with that. You got a good 5 years or so before you need to upgrade the major operating system version, which again is going to be like nothing. That's the other thing that's really nice about it is there's so little to back up, and you can back it up whatever way, you're comfortable with. That, most of us that would think about, touching such a project, it's not a big deal to be like, okay, so, I need to save my IP tables rule set.
And my DHCP config, and that's about it. Like I have a DHCP config that has a couple of MAC addresses to reserve specific IPs for specific hardware, and to know, which a range of IPs to give out on which VLAN, and my firewall rules for like port forwarding and so on. And there's like nothing else.
Yeah, you're talking like 4K total of plain text files.
So what do you do about your access points then? Is that just off-the-shelf stuff?
Yes, it is. There's not a great answer for trying to go open source and get decent performance with access points. There are...
because the other problem is generally you want your access point in a certain place. It's not necessarily where you want to put a whole computer.
Yeah, and there are folks who will... there are a lot of folks who really love OpenWRT. And that is a thing and you can do that, but the interface is still honestly kind of abominable, and the performance can be good or it can just completely stink, and you're not really sure which one you're going to get until you find out you got the one you didn't want, has been my experience, including, I work with some folks who set up the conference Wi-Fi for, open source conferences. And every time they have tried to deviate, from something widely supported, like Ubiquiti or whatever, and go OpenWrt, it's been a mess. It has not been a pleasant experience.
At my house, the whole wireless runs off this $25 little thing that's about the size of a deck of playing cards I bought in Japan that runs in my laundry room, which is about the center of my house. And I have 5 gigahertz and everywhere in the house. And I've, it plugs into a switch and it with DHCP and so on disabled, it just gives out Wi-Fi. What I like about this Japanese one is it has multiple virtual SSIDs and automatically tags the VLAN. And so they just arrive at my FreeBSD router on the right VLAN and magic happens.
5 gigahertz N, you say, you futurist, you.
Yeah, I bought that thing on like my second trip to Japan in like 2014 or something, and that's the last time I touched my Wi-Fi.
My setup's a little different. I've got a large house and I've got a pretty large family. So more devices than I probably, wish were on Wi-Fi, need to be on Wi-Fi and need to work. So I've got wired access points all through the house. And it's currently Ubiquiti set up, the UAP AC lights. They're pretty inexpensive. You can run a software controller to manage all of them, which I do in a virtual machine. Mm-hmm. If I had it to do all over again, I would do largely the same thing, but instead of going Ubiquiti, I would go TP-Link. The access points are a little bit cheaper even, which I don't care about, $60 access points versus $70 access points. I don't really care about that, but they actually perform better and they're a lot more flexible. With the Ubiquiti, you need to be running a software controller. With the TP-Link, you can run a software controller or you can manage them individually with fully functional web interfaces that expose all the functionality, multiple SSIDs, VLANs, everything you can do through the web UI on the individual APs if that's how you want to roll. Or you can get a little dedicated hardware controller TP-Link makes. It's a nice little metal chassis, and it's robust. It works, and unlike Ubiquiti's Cloud Key, it doesn't grenade itself the third time that the power gets removed from it.
That does sound nice.
Wasn't there some controversy about Ubiquiti and GPL stuff?
Yes, but that's probably the least of the controversy with Ubiquiti, honestly. They resolved the GPL thing from what I recall, but they've been increasingly kind of sketchy. Yet haven't necessarily seen all of it over on the Wi-Fi side, but they do security camera products that target kind of that same environment. The more technical side of the SMB world, shading up to the smaller enterprisey stuff. And to begin with, the security camera products were managed a lot like the access points, where you had a dedicated software controller and you install that on a VM or a PC, and it works great. It manages as many cameras as you need it to, and if you need more performance, you put it on bigger hardware, and that's that. Easy peasy. I want to say it was a year and a half, maybe 2 years ago, they deprecated the software controller entirely for this security camera product and started trying to push this dedicated hardware controller for it. And the dedicated hardware controller, it's expensive, and it's another thing that you got to buy, which, pisses off a lot of their market. The folks who install this stuff, right? They're like, oh, well, now I can't just deploy it on whatever. Now I have to buy your thing, and that's new, and I don't like that. Adding insult to injury, the installers who, again, the people who actually buy these things are not the end user typically. It's integrators that, sell and install them to the actual end users. But the actual end users are using, this software to see what's on their cameras. And now all of a sudden, all this software is popping up a notice that, hey, you've got this old janky crap and you need to go buy this thing, the new hardware controller. And if that wasn't bad enough, in a lot of cases, the hardware controller, which only came in one size, one size supposedly fits all, but it couldn't handle as many cameras as a lot of these integrators had in existing functioning setups. So now their customers are coming to them. Why don't I have the thing that I'm supposed to have with this? It's telling me that I need this other thing. And even if they put the other thing in, it will break everything because it can't handle all the cameras.
And wasn't there some metrics collection as well or something?
Yeah, there is concern about that. Ubiquiti was also taking telemetry, and the telemetry that they were taking, they didn't say anything about it when they started taking it. And I believe they actually denied it for a little while until people really rubbed their noses in it. And then they didn't want to talk about what was in it. And finally, I think they're like, okay, you guys, like, here's what's in that telemetry. By then, it's a little late for, a good PR feel out of the thing.
Let alone, allowing you should opt into things like that. Like it shouldn't even be opt out.
Oh, I forgot the best part with that one. So while Ubiquiti was refusing to talk about what was in the telemetry or give anybody an opt out, some folks were actually having issues with it, from what I recall. People who are on like satellite, deployments or whatever that have, very, very limited bandwidth, yada, yada, yada. And also some people, just for the privacy aspect, they're like, no, screw you, you can't have it. So since they weren't given an opt-out and Ubiquiti wouldn't talk about what's going on, people started just, implementing firewall rules to block the outbound connection to Ubiquiti's, telemetry servers. And that would crash the system if they did that.
Wow.
That reminds me, I had a terrible APC power strip that it was like a managed power strip, so you could turn each port on and off manually or whatever. But if you didn't have a mail server configured on it and this weird set of circumstances, the software would basically crash and you'd never be able to get it to work again.
Nice.
Well, and it failed closed, so it just wouldn't work rather than failed open.
Well, no, it worked, but like you couldn't connect to it and give it orders anymore. So it was just like all the switches are on and it won't even tell you how much power you're using anymore, which was the reason to buy the damn thing in the first place.
Yeah, there's fail open, fail closed, and fail dumpster fire.
Yeah, somebody else had a different one that, it failed and eventually it was just like the voltage would sag and eventually one of the ports would just turn off. And it would just be like randomly turning servers off in the middle of the night. And you're like, that's
fine.
And then it's like, oh, so I have to try to replace the entire power strip. How does that work?
No, Alan, that's the Chaos Monkey. I mean, Netflix paid extra for that.
They did.
All right, well, we better get out of here then. Remember, you can email us show@2.5admins.com if you want to get in touch. We'll be back in a couple of weeks then. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you in 2 weeks.